Hello, welcome to SPMM Revision on Demand. In this short podcast, I will discuss various types of data. The term data relates to anything that is measured or observed or manipulated in a study. The data collected in a study needs to be analyzed, and how we do the analysis depends on what type of data we have collected. In the first instance, data can be classified as qualitative and quantitative. Qualitative data arise when individuals fall into separate classes. These classes generally do not have any numerical relationship with one another. For example, males and females. There are two types of qualitative data, nominal data and ordinal data. Nominal data refers to simple categories. The previous example of males versus females is a good example of nominal data. Such kind of nominal data, which has only two classes, is called binary data as well. You can also have nominal data with more than two groups. For example, blood groups, you have A, B, AB, O, etc. So these are categorical data where you have multiple groups. Now, as I said earlier, in nominal data, you cannot have any numerical relationship between the two groups. For example, you cannot say male is better than female or female is higher than male. You cannot make any kind of numerical assumptions based on the group descriptions. Now, ordinal data are a set of ordered categories. For example, consider the answers to an item in a questionnaire. How anxious are you when you wake up in the morning? Number 1, very high. Number 2, high. 3, moderate. 4, slight. 5, not anxious. Though there is an order, one cannot say that the difference between 1 and 2 is same as the difference between 3 and 4. So ordinal data is data which can be ordered, but the intervals are not always equal. Another example is the severity of depression, mild, moderate, and severe. You can see that there is an order, but the difference in the amount of depression between mild and moderate groups may not be the same as the one between moderate and severe groups. Quantitative data are numerical, born out of counting or measuring something. If the values of the measurements are integers, that is, whole numbers, then the data is said to be discrete. Generally, discrete data are limited by the number of values they can have. In this example, number of files in the set refers to a discrete data. If the values of measurements can take any number in a range, for example, cholesterol levels, age, blood pressure, then the data is said to be continuous. Continuous data can take an infinite number of possible values. But in fact, the discrete versus continuous differentiation is not practically useful. Most continuous data can have only a finite set of possible measurements due to limitations of available instruments that can measure them. So most discrete data can be treated in pair with continuous data. Continuous data itself is of two types. Interval data are measurements where the difference between two values is meaningful and constant. For example, the difference between a Hamilton depression score of 40 on week 1 and 20 on week 6 is 20 points drop. But we cannot say that a person with a score of 40 experiences twice as much depression as the one with a score of 20. While differences are meaningful, ratios do not make much sense for interval data. Ratio data have all the properties of an interval variable, but also have a clear definition of 0 point. Hence, besides differences, ratios are also meaningful. Variables such as height and weight are ratio variables. Consider the example of acidity. Acidity is expressed in the units of pH. This is not a ratio variable because pH of 0.0 does not mean absence of acidity. It denotes some acidity. A pH of 6 is not twice as acidic as pH of 3. For these reasons, acidity is an interval data, not a ratio data. In fact, the ratio versus interval differentiation is almost never needed in social and medical research. So most interval data are treated in par with ratio data by statisticians. As long as you know that your data is of continuous type, you can choose certain statistical tests. This table is helpful to understand the properties of the different data types. With nominal data, we can count the frequency and measure the mode. That's all we can do. With ordinal data, we can measure the mode, we can measure the median as well, because we are able to put things in some sort of rank order. With interval data, we can measure mode, we can measure median, we can also measure mean. In addition, differences are meaningful for interval data. With ratio data, we can measure all of these properties. In addition, we can also obtain ratios, which are meaningful, fractions. Nominal and ordinal data are analyzed using non-parametric tests, while most other measured continuous data are analyzed using parametric tests. We will see the difference between parametric and non-parametric tests in our later vodcasts. Now look at this table. This is an exercise to test our skills of classifying data. From the table shown here, identify the item that has been measured as ordinal data. Socioeconomic status has been quantified in quintiles. There is an order progressing from lower status to higher status, but it is not continuous data. This is ordinal data. What type of data is presence of major depressive disorder? As you can imagine, this is measured using an yes or no response. You either have major depression or you do not. So it is a binary categorical data. Here is the tip. When you are given an MCQ or an EMI, think, how was this data originally recorded in the study for each patient? This is the question, the answer for which will help you to choose the type of data that has been collected. Let's say another example. What type of measurement is this? Pain is rated on a scale of 0 to 5. This is a visual analog scale. Such visual analog scales use Likert-like measurements. Anything which is measured in a Likert-like fashion, from a low value to high value in a rank order, is ordinal data. For rating scales such as HAM-D, Hamilton Depression Scale, that is shown here, though individual items are Likert-like and so ordinal, the summed final score behaves as interval data. So the total HAM-D score is an interval data or a continuous data. Now it's time to ask yourself a few questions. Thank you for choosing SPMM course for your revision.